Welcome to Assessment 1 2904 E&V. I'm Natasha Lumley, and today I will present an investigation and comparison into Griffith Gold Coast G39 and G40. Probably one of the weakest points of the buildings was their connection to the local area. The campus itself was rated 49 out of 100, and this walkability score can be seen in Figure 3. But there are not enough services within this 20-minute radius to justify walking over car use. Fortunately, G39 and 40 are both reasonably accessible among the campus, connected to facilities within it. However, access to the campus is predominantly through cars regardless of the trams. Even though these buildings are right next to the tram stops in Figure 1 and Figure 2, we can see this. A lot of people still drive to uni because of the north and south direction of the tram. It doesn't really reach everyone. Indoor air quality in both these structures is managed by artificial ventilation through ducted AC systems and extraction fans for hazardous chemicals, materials in labs and workshops. However, in G39 there is a potential cross breeze that can be achieved between the academic offices on the eastern wing, which is demonstrated in Figure 5. However, this is a very small section of the building and is unlikely to occur among staff keeping windows and doors open. A well-sealed multi-storey building is more ideal, as the windows cannot be opened all the time at higher heights. An effective filtering system is also necessary in this building because it is fully sealed. Chemical odours still get trapped in the aircon. Both these structures are also effective at managing thermal comfort and daylight for their climate. The climate of Southport is warm, humid or subtropical, and G39 and G40 require significant cooling in summer and some warmth in winter. G39 and G40 are heated in winter through solar radiation penetrating through the glass, and the glare on these windows are prevented through awnings and laminated glass, preventing the harsh rays, but it also still allows the heat to come through, and the awnings work so that they're horizontal, flat on, preventing the high angle summer sunlight and allowing the lower angle winter light to come in. They also use concrete for increasing thermal mass to heat it at night time, and unfortunately though there is a few design flaws in G39, as that northwestern wall does not get a lot of sunlight during the day, so that could be very cold during winter. In summer, both buildings are relatively sealed to maximise mechanical cooling. Extensive awnings on the east and west faces to prevent the higher angle hot radiation and glare from morning and afternoon sun exist. High thermal mass of the concrete also to reduce heat transfer through the day and release at night time with less occupants, and low thermal mass through the ceiling to let the heat out. Blinds for the occupants are on the sides where the computers are in G39, but this reduces natural daylight. G40 on the other hand is fully sealed and does not have as many computer labs, so it utilises its long glass south and north walls for classrooms, daylighting them. The passive design to prevent solar radiation and glare through insulation and glazing also blocks out noise pollution from the road and tram, and this can be seen in Figure 8 and 9. Both buildings did score a 6-star rating on the neighbours, but this shouldn't be a rating used for university buildings due to its mixed-use purpose with the electricity. However, it did seem quite accurate. Looking at the energy usage of the building, it was well below the consumption of standard university buildings. Griffith's sustainability plan highlighted some goals that these buildings could aim to improve on. Specifically G39, it should either aim to maximise natural cross breezes or encourage a sealed building as much as possible to reduce GHG emissions and energy consumption. It could also aim to use more recycled materials in future expansions or renovations. The building has a large roof plan that could be covered in solar panels to maximise solar energy. As you can see in Figure 12 and 13, both buildings were very competitive against other campus buildings across the globe in subtropical climates in terms of their energy consumption. However, G40 is using considerable power to heat during winter and could utilise a renewable energy source to instead of coal power. Nonetheless, G40 collects its own water, and this is very good for the environment, and they both utilise natural vegetation for cooling and visual comfort. As these buildings are some of the newest constructions on campus, they're both very sustainable designs. However, there is always room for improvement. Thank you for listening.